Yes, Sasrika students. So today, once again, we discuss about domain and range of trigonometric functions. Now, students, first we will discuss what is domain of a trigonometric function. Well, the definition is domain of a trigonometric function consists of all the values that you can use as input, that can be used as input into the angles. It means the values for which trigonometric functions are defined. Values for which these functions are defined. Let us understand the meaning of this. All the values of theta, when we talk about sine theta, all the values of theta for which sine theta is defined. I'm talking about values, all the values input into the angles, means all the values of the angles. Like for example, sine theta or cos theta, you won't be able to understand better. Better we understand tan theta. Now, if we say, do all the real values of theta can be considered domain of tan theta? Let us see the answer. Well, you take tan theta from here, theta from here. This is theta 0. This is theta pi by 2. This here theta is pi, and here theta is 3 pi by 2. Here theta is 2 pi. Well, tan theta is can be defined for all the values of theta except for the values where cos theta is 0. Tan theta is equal to sine theta by cos theta. Now, theta. Ishma, when cos theta is 0, whenever cos theta is 0, tan theta will not be defined. So, I'm talking about all the values of angles for which functions are defined. That means for particular value of theta, tan theta is not defined. Why? Because if I divide sine theta by 0, it will give me error, not defined. Now let's see for which value of theta tan theta is not defined. Yes, Ishma, can you tell? When theta would
90.
perfectly right. When theta will be equal to pi by 2, cos theta would be 0, or even cos of pi by 2, or even cos of 3 pi by 2. Here base will be 0. So cos theta will be 0, tan theta will not be defined. So that means all the real values of theta are not the domain of tan theta. All the values of theta are domain except these values, pi by 2, 3 pi by 2, and then multiples of this pi by 2. So this is exactly the meaning of domain. Now, in this lecture, we are going to define the domain for all the trigonometric ratios. Now, students, the second is range. Whatever is the domain of any trigonometric function, what is the value of the trigonometric functions? That consists of range, values of trigonometric functions. In other words, you can say the output. You give input, you give input. What are the input? Input are the values of theta. You give input to trigonometric function. And what is the output? Output are the values of the function. For example, I give input value of pi by 2 to a trigonometric function sine theta. And what is the output I am getting, Ishma? Sine pi by 2 will be If I give input value pi by 2 to this trigonometric function sine theta, what is the output? Output sine pi by 2 is 1. So this 1 is the range and this pi by 2 is the domain. Well, this is one value. There can be infinite values like this, and there might be infinite values of the output. So output values, set of output values make the range, like we say range of the function, and the set of all the input possible values of theta for which a trigonometric function is defined is known as domain of the trigonometric function. Let's discuss one by one. All right. So domain, range, and graph of each one of the 6 trigonometric functions are to be discussed now, right? So first we take sine theta. We'll take trigonometric function. In this trigonometric function, first we will take sine theta. Then we will talk about its domain. We'll define the domain. After that, we will define its range. After defining range, we will try to draw the graph of both domain. We will take domain on x-axis and we will take range on y-axis. So we will see how range varies with the domain. All right, let's go. Fine. All right. So let me make little columns, here. Okay, give me 1 minute. Yeah. So this will be the trigonometric function. Here I will define the domain of the trigonometric function. Here I will define the range of the, here I will define the range of the trigonometric function. And here I will go for the graph of trigonometric function. So just 1 second and then I start. All right. So first of all, I'll take sine theta. And then I will quickly I'll go for cos theta and this here only, 2 only, fine. Okay, guys. So let me start. Yes, sine theta. Now, what is the domain of sine theta? You see, sine theta is defined for all the possible values of theta, all possible real values of theta. So I'll represent it by R. All right. So set of real values, for the set of real values of R is all possible real values of, if it is sine theta, I'll write theta. If it is sine x, I'll write all possible values of x. All right. Okay. So what is the range? Now, students, you see that any of you students can tell me what is the maximum value of sine theta? Do you remember? And what is the minimum value of sine theta? Anybody remembers? Maximum and
0 and 1.
What is the minimum value of sine theta, Ishma?
0.
No, it's still less than that, baby. It's -1 and maximum value is 1. See how it comes. So we'll take theta in anti-clockwise direction. If the, theta is 0, we know this is our domain, input value to the domain, and the corresponding range, like the value for the range, not range, the value for the range here would be 0 because perpendicular is 0. As theta is increasing, the sine theta is also increasing. Output is all. As input is increasing, sine theta also is increasing. Why? Because perpendicular is increasing, right? And this is the point where perpendicular becomes equal to the hypotenuse, making sine theta as 1 at theta is equal to pi by 2. Am I right? So, but as theta comes down, not comes down, it further increases. What happens? Sine theta starts, yes, Ishma, the value of sine theta starts decreasing. Why? Because perpendicular is decreasing. Hypotenuse remains same. So here it decreases to 0. All right. So it increases from 0 to 1. Then it decreases from 1, 2, 0. But then again, here it becomes -1. It further decreases. All right, because perpendicular is negative. So it becomes -1. So the maximum value of sine theta is 1. Minimum value is -1. Doesn't matter what is the value of theta. And also, there are no hiccups like tan theta we discussed before. Like tan theta is not defined for some particular values of theta, especially pi by 2, 3 pi by 2, and then again 5 by 2, then again 7 pi by 2, like that. No problem with sine theta. So here it's definable for all values of theta. So it's just I'm sorry, it's just a explanation I gave you. So, but then what is the range of sine theta? Well, I will say -1 and 1. Now, which bracket I will use, Ishma? Will I use this bracket or I will use square bracket? So remember when we studied set, square bracket means this value is included. Well, sine theta can have the value of -1, 1. So we will not use, we will use square brackets, right? This is the meaning of this. Understood, students? Please tell me. Perfectly understood? Come on, students. Please give a thumbs up if you have understood. So we go further. All right. So, yes, students. So, after having defined the range, let's draw the graph of sin x. Once you know how to draw a graph of sin x and cos x, other graphs you can draw yourself very easily. Yeah, I'll help you in that even if there's some problem. Huh? So let's say this is our x-axis. Understand properly. If this is our x-axis, students, let's say on x-axis we plan to take theta. Now, what are the values of theta? Domain or range? Values of theta are domain. So that means domain we have taken on x-axis and the range we have taken on y-axis. This is our range on y-axis, right? So how do we do it? So let's say this is 0, means 0 radian. Okay, now this is, let's say, pi by 2 radian, right? So same distance here would be minus pi by 2, right? I'm just taking values like I take 1, 2, 3, 4. So what will be this, Ishma? If this is pi by 2, which is, and what will be this? Pi by 2 plus pi by 2 is?
Pi.
Correct. So, I'm sorry, this will be minus pi by 2 and this will be minus pi. Now, I want you to divide pi by 2 into 3 parts. 1, 2, 3, right? To get a idea about how this graph is having curved shape. So then what will be this angle? If this is 90, this will be 30. So 30 is pi by 6. Am I right? 30 is pi by 6. Pi by 6. So this angle would be, so it will be 30, 60. So it will be pi by 3. Right? This will be pi by 2. Am I right? So this is 30, this is 60, and this is 90, right? Gap of 30 degrees. So you see, what is sine 30? So now one more thing, So you see that I draw one more line here. One more line here. Let's say this is 1. This is 1, then this is minus. This is minus 1. Okay, well, this is 1 and this is minus 1. Once again, this is 1 and this is minus 1. This is 0. Numeric, the value 1, 1 minus 1, right? Okay. So I'm using y-axis for plotting the range. Okay. So guys, very simple. This is the value of sine theta. This is theta, this is sine theta, right? So at pi by 6, what is the value of sine theta, Ishma? Sine pi by 6 is 1 by 2. So that will be in the center, right? This point will be in the center. Am I right? At pi by 6, it will be this. At pi by 3, it will be It will be pi by 3 under
root 3 by 2.
Very good. So that will be approximately, if I'm right, 1.7. So it will be approximately 0.8. Am I right? So 0.8 will be still closer to 1 if I'm right. So we'll plot it here. Am I right? Is it right, Ishma? And sine pi by 2 would be 1. So this point will be here. So what will be the shape of my graph? The shape of my graph would be, it will be like this. It will be a curve, right? This is the shape of my graph. It's a curve. And why it's a curve? It's plain. Okay, you can take more values, sine 15, more values. You'll see exactly it's a curve. Sine pi by 2. Okay. So what about sine pi? Similarly, you can take 3, and then what is sine pi? See, sine pi by 2 is 1, sine pi is 0. Am I right? So here it will be 0. So this 0 means again it will be a curve here. Okay. So it will be a curve here also. Right. So it's a curve here. Right. Great. So it's like a crust. Okay. So now again, if I talk about 3 pi by 2, this is pi. Well, this is pi, then this is 2 pi. Right? If this much is pi, then I can say possibly this much is 2 pi. This much is 2 pi. Okay. So at 2 pi, what is the value for sine? Yes, Ishma. 2 pi means 0. What is the value for sine at 2 pi? This is 2 pi.
0.
Again 0. So it will be here. Point will be here. And what about this point is what? Between pi and 2 pi is what point? Can you tell me? It will be 3 pi by 2. This point. This point is 3 pi by 2. This is pi by 2. This is 2 pi by 2. Or simply pi. Well, this is 3 pi by 2. And this is 4 pi by 2. 2 pi is equal to 4 pi by 2. Am I right? Pi by 2. One more pi by 2. Pi by 2. Pi by 2. Okay. So 3 pi by 2. What is the value? Tell me, Ishma. Sine 3 pi by 2. What is the value for sine theta? Right. Sine 3 pi by 2 is what? Sine pi by 2 is 1. So exactly opposite to this, it will be minus 1. Okay. So minus 1 means it will be here. This will be here. Sine pi by will be like this. So the graph would be like this. Okay. So this will be the graph, guys. Right. So I get another trough. It's like a trough. This is cross. This is the trough. Okay, guys. And now you see when I go backwards. So minus pi by 2. Now, how do I draw minus pi by 2? See, so very simple, students. If this is 0, yes, Ishma, how can I draw minus pi by 2, beta? If I draw pi by 2, it will be anti-clockwise. If I draw pi by 2, it will be, yes, anyone can speak?
Clockwise.
Clockwise, very good. Clockwise, this is pi by 2. I'm sorry, this is minus pi by 2. Very good. If I go clockwise. So what is the value for sine at minus pi by 2? Can you please tell me? Minus pi by 2 is
0.
No, never. Minus pi by 2 is equivalent to 3 pi by 2. Sine is 0 only here. Perpendicular is 0 only on this line.
1.
Not 1. You're wrong. Sine is 1 only here.
Minus 1.
Here it will be minus 1. Beautiful. So sine minus pi by 2 is here. The value of sine is minus 1. So guys, this graph would be like this. All right. So it will be like this. Am I right? So again, what about minus pi? Minus pi, I will go like this. This is minus pi. So what is the value for sine at minus pi? Perpendicular is 0. Here also perpendicular 0. Minus pi also 0. So it will be here. That's why it's like this. Okay. This is minus pi. Am I right? Am I right, Ishma? How this comes, cup comes. So this is exactly the graph of sine theta. Beautifully drawn. So if you just draw further values, it will go like this, like this, like this, you know. Another crust, then trough, crust, trough, crust, trough. This is also known as sine wave. You know, when we talk about oscillations and wave motion, we call it sinusoidal wave or sine wave. Okay. So quickly, you know, now we can understand and possibly see how do we draw cos theta. Okay, fine. Students, just give me a thumbs up. Have you understood perfectly? How do we draw sine x curve or sine theta curve?
Yes, sir.
So happy. Okay, guys. So now we're going to go for cos theta curve, right? Okay. So I'll not explain you much because it's same way. It's same way. So you'll get the idea. So now t function is what? T function is, student, cos x or cos theta. All right. So when we say cos theta, what is the value? So any value of theta is okay, acceptable. So R is the domain, all real values of theta. And range, yes, range, cos 0. When we talk about cos 0 is what? Anyone? The base is maximum, cos 0 is 1. And cos pi, you see, here, cos 0 is 1, cos 0 is 1, and cos 90 is 0. Cos 90 is 0, and cos 0 is 1. And here, it is cos pi. So cos pi is again minus 1. So cos theta also dwindles between minus 1 and 1. No matter how big angle you keep circulating, keep circulating, keep circulating. You know, you go for 2 pi, 3 pi, 4 pi, 5 pi, 1000 pi. But cos theta would just dwindle between minus 1 and 1. Very interesting. So Ishma, can you tell what will be the range of cos theta?
-1, 1.
Oh, that's beautiful. Enclosed with which bracket? Square bracket. Why?
Square.
1 are included. These values are, Ishma. These values are
Included.
included. Well, if they were not included, I would have put these brackets. I don't know what do we call. What do we call this parenthesis? Do you know? These are, I don't know, what do we call this, uh, curve brackets or whatever it is, they're included. Okay, so Ishma, now what I do, I again draw what? I take theta on the x-axis and I take cos theta. The value of cos theta upwards or downwards, that is towards y-axis or negative y-axis. Okay, again, I know that what? Maximum value of cos theta is what? Come on, plus 1. And minimum value of cos theta is, come on, minus 1. All right, so that's why I've drawn this. Beautiful. So now see that this is, guys, this is my 0. All right, this is my pi. And this is my, let's say this is my 2 pi. Or I go for here only, Let's say this is my pi. Sorry. We'll get your mind will catch what's been discussed before with this compare beautifully. Well, this is pi and this is 2 pi. Okay. So guys, here it will be now minus, this is pi, so this will be minus pi and this will be minus 2 pi. Okay. It's just like I take 1, 2, minus 1, minus 2. Okay. So now, where the point will rise, Ishma, at cos 0. When the angle is in degree or radian 0, cos 0 is what? What is cos 0?
1.
Cos 0 is 1. Why? Simply because you see that this is theta, theta is 0. So, when theta was increasing, so my base was increasing. When theta was decreasing, my base was increasing. When theta became close to 0, my base is approximately equal to radius. When theta became 0, my base and radius all became same. So cos theta cos 0. Cos 0 is radius by radius. You could say like this, that's equal to 1. Just to remind you how cos 0 is 1. And cos theta, the base becomes 0. So cos 90 is 0. So cos 0 is 1. So only difference between sine curve and cos curve is, Ishma, at 0, cos curve starts from here. Why? Because sine 0 is 0 and cos 0 is 1. Okay, cos 0 is 1. So now I will take again, this is pi by 2, and I'll see what is cos. Can you tell me what is cos pi by 2? What's the value of cos pi by 2? Yes, come on guys. What is the value of cos pi by 2? Cos pi, here it's 0. As the theta increases, the base decreases, so finally base becomes 0 at 90 degrees. So, yes, Ishma, cos pi by 2 is? Come on. Come on.
0.
Cos pi by 2 is 0. So, this will be the point. So, I'll take intermediate points now. Again, this will be pi by 6. So, what is the value for cos pi by 6? It is equal to sine pi by 3. So this will be this is under root 3 by 2, the 0.8. So 0.8 will be here, am I right? Okay, so pi by 2 would be 0.5. So that will be here, okay. And it will be here, okay. So I just join the points. And when I join the points, I get a curve like this. I get a curve like this. So when I join, I get a curve like this. I'm joining this. So I get this curve. I'm joining this, okay? So now, what about pi? What's the value? Cos pi. And let's see, what is this? This is minus pi by 2. So what is, this is pi by 2 or minus pi by 2? Both are 0. So here also it's 0. Okay, so it will be like this. Very simple. So it will be like this. So the curve will be like this. Okay, fine. This is fine. And then at cos pi, yes, students, at cos pi is cos pi. Okay, cos pi. Cos pi is this. Okay, so cos pi, you see, students, cos 0 is 1, cos pi is minus 1. So it will be here. So it will go like this. It will go like this. And then cos pi, yes, students, can anyone tell me now? Further, so this will be 3 pi by 2. This will be 3 pi by 2. Pi by 2, 2 pi by 2, 3 pi by 2. 3 pi by 2, let's see. Here, 3 pi by 2. Again, it will be 0. 3 pi by 2, it will be 0. Okay, so it will be like this. So it will be like this. Okay. So it will be like this. Okay. It will be like this. All right, students. And then further, it will go like this. You got it? It will go like this. How it will go like this? Because at 2 pi is complete revolution. Again, it will be 1. So 2 pi, again, it will touch the top. So similarly, students, it will go down, and, it will dwindle like this. So when there is a simple thing, students, when there is a crest in, when the sine curve touches the maximum value, pi by 2, the cos curve touches the, you can say touches the 0.